Number 12 asks, does y squared plus 2x equals 7 define y as a function of x? So let's try to solve for y and see if we can define y as a function of x. So let's do that. So we'll subtract 2x from both sides. And then square root both sides, but we're going to have to do the plus minus square root of both sides. Now because of this plus minus, the answer is no. Y is not a function of x. Every x value that we substitute in has two different corresponding y values, one for the plus and one for the minus. In order for something to be a function, every x value must correspond to only one y value. So the answer here is no. In number 13, we want to substitute in 3x plus 2 into our function. So here's our function, and let's write it with parentheses, just blank parentheses instead of x. Then whatever we want to substitute in, we'll put here and here. So if we want to form f of 3x minus 2, well, we'll put the 3x minus 2 there and the 3x minus 2 here. So this is it. This is f of 3x minus 2. Now, let's say we want to simplify this. We'll open parentheses. Multiply through by minus 2 here and here. All right, so here we have minus 6x. And here minus 2 minus 2, that's plus 4. So that's 11 minus 6x. Number 14 is a find the domain question. Now remember, the domain is basically all possible x values. All right, so let's look at this first function in part A. And I'm going to factor the denominator because I know that x values that make the denominator 0 must be excluded from the domain. All right, so let's factor this. This factors as x minus 7, x plus 2. Okay, let's just make sure that's correct. The middle term, minus 7x plus 2x, gives us this minus 5x. All right, so we want to make sure that this is not equal to 0. The denominator can't be 0. It's 0 when x equals 7 and when x equals minus 2. So we see from the first factor, we're going to require that x not be 7, and from the second, we're going to require that x not be equal to minus 2. So the domain we can write as x not equal to 7 and x not equal to minus 2. All right, in part B, we have f of x equal to x minus 2 over the square root of x minus 5. Now, again, the denominator can't be 0, but also we require that anything underneath a square root must be greater than or equal to 0. Combining these two, that the denominator can't be 0 and this must be greater than or equal to 0, we'll just simplify that and say, well, let's require that what's under the square root, x minus 5, be strictly greater than 0. All right, then the denominator won't be equal to 0, and what's underneath the square root will be positive. All right, so add 5 to both sides, and we have the domain x greater than 5. That's our domain. In 15, we have this equation over here, and we want to know, is this point minus 3, 4 on the graph of this equation? Well, the way we determine that is just by substituting in. We'll put x equal to minus 3 and y equal to 4. So let's do that here. So let's see, is minus 3 squared plus 4 squared equal to 25. Let's just work that out. 9 plus 16 is equal to 25. So the answer is yes. The point is on the graph. In 16, we want to find the x and y intercepts. Well, let's remember that to find an x-intercept, what we do is we set y equal to 0. So let's do that here. Here, f of x is really another way of writing y. All right, so we want to set this equal to 0, so we'll write 0 equal to x cubed minus 9x. And now just we'll factor this in order to see when this is equal to 0. Factor and set the factors equal to 0. Okay, we can factor x squared minus 9 into x plus 3 times x minus 3. Okay, so now we've factored. We have 0 on one side, and we've factored, and this expression here is 0. This factored expression will be equal to 0 when any of the individual factors are equal to 0. So that is when x equals 0, or for the second factor when x is equal to negative 3, or for the third factor when x is equal to 3. So these are the three x-intercepts. Written in point form, this one would be 0, 0. This one would be minus 3, comma 0. And this one would be 3, 0. Okay, now for y-intercepts, we just set x equal to 0. So let's do that, and we have y equal to 0 cubed minus 9 times 0, that's 0. So the y-intercept is 0, comma 0. Number 17 asks to find all x values such that x6 is a point on this graph. So that is all x values such that y is equal to 6. Now remember, f of x is another way of writing y. So what we're going to do is just replace y with 6 and solve for x. Let's set this equal to 0 and try the factor. So we're going to just subtract 6 from both sides. So we have 0 is equal to x squared plus x minus 6. And now let's just see if this factors. And we can factor this as x plus 3, x minus 2. Okay, 3 times minus 2, that's the minus 6 over there. And for the middle term, 3x minus 2x is plus x. All right, and now let's finish solving this. We factored, and we have 0 on one side, so we can set each factor equal to 0. The first factor is 0 when x is equal to minus 3, and the second factor is 0 when x is equal to 2. So these are two x values. Such that when we substitute in these x values, we get 6. In number 18, we're asking if these functions are even, odd, or neither. So let's just remember that a function is even when you substitute in minus x and you get the same function back, and odd when you substitute in minus x and you get the negative of the original function. All right, so let's do that. Let's look at, for a, let's look at f of minus x. So in the numerator we have minus x cubed plus 5 times minus x over minus x, subtract minus x to the 5th, just start removing parentheses. Here we have, because the exponent's negative, we get minus x cubed, minus 5x. Here we have minus x, and plus x to the fifth. At first glance, this doesn't look like the original, but if we multiply top and bottom here by -1, and you're allowed to multiply numerator and denominator of a fraction by the same number, we end up with the original. We end up with x cubed plus 5x over x minus x to the fifth. So we'll say, yes, this one's even. And now let's test the other one. Let's test b. We're going to substitute in minus x. And here we have minus x squared plus 5. And here we have minus x cubed minus x. Remove parentheses. Minus x squared is x squared. Here we have minus x cubed plus x. Okay, compared to the original, the numerator is the same. The denominator is the negative of the original denominator. So if we just factor out this -1 or this negative, we can rewrite this as with the negative in front of everything. And let's rewrite this denominator as x cubed minus x. So we just pulled this negative out in front. Notice if we place it in the denominator and multiply through, we'll get this minus x cubed plus x. So what do we have here? We have the negative of the original. We have, this is equal to minus f of x. So f of minus x is equal to minus f of x. Well, that's exactly the condition for odd. So this one's odd. In number 19, we want to find the average rate of change of this function. So let me write down the general formula. The average rate of change from x equal a to x equal b is f of b minus f of a over b minus a. All right, so that's the average rate of change from a to b. So now we're looking at this function, and we're looking at 0 to 2. So we have, in our case, this is equal to, okay, first 2 minus 0, I'll put that here, and f of 2 minus f of 0. All right, so let's work that out. First, f of 2, looking at our function, we're substituting in 2. That's 3 minus 2 squared. Okay, let's put that in parentheses. That's f of 2. Now f of 0 is 3 minus 0 squared over 2 minus 0. All right, so in the denominator we just have 2. And here I'll just write on top what we have. We have 3 minus 4. So that's minus 1. And this is just 3 over here. Minus 1 subtract 3. So we have minus 4 over 2, which is negative 2. So that's the average rate of change. The average rate of change is negative 2.